Everyone, in this video we're going to be taking a look at Lerps, and Lerps is going to be an integral part for what we are going to do to get our enemy to be able to jump between these two different platforms. So we're going to perform a Lerp in a separate scene just to get an example of how Lerps work. So I'm going to save this scene and then create a new scene. And I'm going to save this scene as Lerps. So I'll put this in my scenes folder, and we'll call this Lerps. So Lerps can be used in a variety of different areas. They could be used to move one object to another object. We could have used it in our pickup script earlier in the mouse pickup video, where we could have lerped between the position that the object was sitting at and our player's hand position, and it would have appeared to be picking up the object. In this particular case, we're going to use ArrayCast to lerp between the point that our mouse is pointing on the screen and a particular object that we want to be able to move to that lerp position. We're then going to use this in our enemy script to be able to lerp from their position in space to where we want them to move to using the navigation mesh links. But in this example, we're just going to create a plane. So I'm going to go to 3D object, plane, and I'll increase the size of this a little bit, and I'm also going to go to 3D object and create a cube. And this is going to be the thing that we're going to be lerping around the surface of this object. So to get started, I think what we're going to do is create a script, and I'll call this script lerp test. So I'm going to go to my scripts folder and create a new script and call it lerp test. And let's open that up inside of Visual Studio. Alright, so we start off with a start and an end function, with our start function, and we're going to create a integer for our floor mask. So I'm going to create a public int, and we'll call this floor mask. I'm also going to create a public variable for our camera. And I think in the start function, what we're going to do is we're going to look for a layer mask. So we will set floor mask equal to layer mask dot get mask, and we're going to look for the floor. And this is the same thing that we use when doing our ground check in the videos where we're doing the character controller. Alright, so the next thing we're going to need to do is in the update function, we're going to be checking for mouse position. So I'm going to say if, and inside of if, we're going to say if input.getMouseButtonDown. Whoops. Dot get mouse button down is 0, then what we're going to do is we're going to call a function called pointer, not pointer type, but pointer. Pointer type is a built-in function. And what we're going to do is right click this and then go to quick actions and refactoring, and I want to generate the method pointer below here. So it's going to automatically create that function for us. Alright, so the first thing we're going to do is check for the raycast. So we're going to create a ray, make sure you delete that throw example there. Basically what that does is if you refactor a function, it makes it so that it doesn't throw an error. So we'll say ray, cam ray, and we'll set this equal to, called it main camera, right? Main camera. Dot screencast array, screen point array. I'm sorry. Dot screen. Screen point array. And in our screen point array, we're going to be looking for our input dot mouse position. And we're going to be basically using that to create where we're going to create the raycast from. The next thing will be our raycast hit. And our raycast hit is going to just be floor hit, so wherever we hit the floor. Alright, so we've got floor hit there, and what we'll do is we'll perform our raycast just like we did with some of our other interactions. So I'll say if physics.raycast So physics.raycast, and we'll send it our parameters of camRay out, and the out we're going to be looking for is floor hit, and we're going to do this 1,000 units, and we're also going to be looking for our floor mask. Okay, so that's just performing a raycast interactivity stuff that we covered several weeks ago. Okay. Alright, so now what we're going to do is generate some points here to be able to do our lerp. Okay, and the lerp is literally one line of code from here. We're going to create a vector 3, and we're going to set that vector 3 to floor POS. And floor POS is going to equal floor hit dot point. So basically whatever our raycast is colliding with, that point that our raycast is colliding with on that plane inside of our scene. Then we'll take the cube, this is going to be on our cube, and set its transform dot position, and we're going to set it equal to a vector 3 dot lerp. And lerp stands for linear interpolation. It allows you to interpolate between 2 points. So the 2 points that we're going to want to interpolate between are wherever our cube is, so the transform dot position of the cube, and the floor POS that we just generated from the hit. The last parameter of this is how long it's going to take to interpolate between those 2 points. So we'll hard code a value here of 10, and then we're going to multiply that by time dot delta time. Now that should do it. So the first value is where we're at, or where we're starting. The second value is where we want to be, and then the amount of time it's going to take to get there. Okay, and that's what linear interpolation does, and it's really useful for a lot of different effects and things that you can do. So we'll save this, and I'm going to jump back into the editor here, and I'm going to select Lerp Cube and drag Lerp Test onto Lerp Cube, and then I'm going to drag the main camera onto Lerp Cube. And I'm just going to rotate my view around here, and then select the camera, and go to game object align with view so that it aligns it with the view. Now if we hit play, the cube, oops, I think I need to add a rigid body to the cube here so that it falls to the ground. Actually, let's try this again. So the problem is the floor mask. So let's see here. let's set it to ground, and ground is number 8. Okay, so I'm going to create this. I set the plane to be ground, go to the cube, and then type in 8 here. Now let's hit play. And still nothing. So let's try this. Let's go in here and open up our script here, and let's change this to ground, since we already have a layer set up for ground. So I'll change this in the start, and then save it. And let's see here. Go back to cube. I have it set to 8 here. So there it is. And you can see as I click, it starts to move it towards our player here. So instead of it just clicking to lerp between those points, let's open up our code again, and let's just comment out the if statements here. So we'll just call pointer over and over again here. And if we hit play, we should see that wherever I move the mouse now, this object will move too, continuously. Pretty cool, right? Even if I move it to here, you'll see it stops. It doesn't start again until I move it till the end of the plane. If I go all the way around to the other side, you'll see that it moves there. Move it to here, move it to there. Pretty neat, right? So that's the basics of how a lerp works in between two positions. In the next video, we'll take a look at how we can add this to the enemy to make the enemy move or jump, like as if they're lerping. Use the lerp to make them move or jump from one position to the other when they're hitting the nav mesh links.